Okay, so on these, we have to find all real numbers that satisfy the equation using radian measure. So your 12 and 13 are similar. I think 12 is harder. So I'm going to work it out, and then I'll explain some of the differences for 13. So the thing that makes 12 different is that my trig function is not isolated. I have this 2 that's being multiplied out front, and I have this minus 3, or minus radical 3, that's being subtracted at the end. So the first thing I need to do is isolate the trig function, which is sine of 2x. So I'm going to move the negative radical 3 over. It's going to become positive radical 3. And now sine of 2x is being multiplied by 2, so I'm going to divide both sides by 2. So I have sine of 2x is equal to radical 3 over 2. Now, the way that I think about it is my argument here being 2x is a little odd because we're not used to having a number in the argument being multiplied by the x. So I'm going to rewrite this so that the 2x is the same thing as alpha. So I'm going to use basically a u substitution, and I'm going to rewrite this as sine of alpha is radical 3 over 2. Now, I need to know what angles give a ratio for radical 3 over 2. So first, because my ratio is positive, I know that this must be in the first or second quadrant because that's where sine is positive. All students take calculus. So I'm looking either here in the first quadrant or I'm looking here in the second quadrant. Two possible answers. So I want to know what is the angle here. Sine is the opposite, is radical 3 over the hypotenuse is 2. That means my angle, where the question mark is, must be a 60-degree angle. And the same thing here, this angle must also be a 60-degree angle, which means how much did I rotate to get there? I rotated 120 degrees to get there. So really, I have found two solutions for alpha. That would be alpha could be equal to 60 degrees, or alpha could be equal to 120 degrees. But remember, this problem didn't start in terms of alpha. It started in terms of x. So I'm going to plug this in for alpha, and I'm going to plug this one in for alpha, and I'm going to solve each one. So here, if 2x was equal to 60, I divide both sides by 2. That tells me that the x value could be 30 degrees. Here, if I plug in 120 for alpha, that's going to give me 2x equals 120, divide by 2. That tells me the x could be 60. So I have two possible solutions. They could be at 30 degrees or at 60 degrees. Now, our answer here has to be in terms of radians. So I'm going to convert this from degrees to radians. So 30 degrees is pi over 6. And 60 degrees would be pi over 3. Okay, that's the first part. I found the two angles. Now, typically, sine and cosine repeat themselves every 2 pi radians. That's why the period of those trig functions is 2 pi. It repeats every 2 pi. So on our answer, we have to account for all possible answers. So we normally add or subtract 2k pi to this value to get another valid solution. Okay, but this time it's not going to be 2k pi because this argument was multiplied by 2. So think about how this changed the period. So if there was a 2 being multiplied by the x on the inside, we would take the original period, which was 2 pi, and we would divide it by 2 to say the period of my new function is pi instead of 2 pi. So we would do the same thing here. Instead of adding or subtracting 2k pi, this time we're going to add or subtract 1k pi, or just k pi, or pi k to both of these. So I'm going to write one of them as pi k, one is k pi. It really doesn't matter. Either way, those are both valid. So this would be your answers for 12. 13 is similar. The only difference for 13 is it's a tangent function. So where sine and cosine have a default period of 2 pi, tangents period is pi. So we would do all the same steps, but we would start with k pi here instead of 2k pi, and then we would adjust accordingly depending on what was being multiplied in front of the x.